Let's suppose that we wanted to multiply two mixed numbers together. For example, let's suppose we wanted to multiply 2 1/4 times 8 2/3. Now, in theory, we could pull the same expanded form move that we did for the mixed numbers, remembering that 2 1/4 is 2 plus 1/4, and 8 2/3 is 8 plus 2/3. And then, just like we did for the whole numbers, we could sketch out an area, 8 plus 2/3, 2 plus 1/4. And then in each box we could do the multiplication. 2 times 8, 2 times 2/3, 8 times 1/4, and 1/4 times 2/3. Well, 2 times 8, that's easy, that's 16. 8 times 1/4, thinking of this as 8 wholes times 1/4, that's 8/4, of course, which, canceling a common 4, is 2 wholes, or 2. 2 times 2/3, that's 2 wholes times 2/3. 2 times 2 is 4, 1 times 3 is 3, and 1/4 times 2/3, that's 1 times 2 is 2, 4 times 3 is 12, canceling out a common 2, that's 1/6. So what's the area of the whole box then? It'll be 16 plus 2 plus 4/3 plus 1/6. All right, look at the bad things that happened here. The first bad thing that happened was these are unlike fractions. In order to add these, we're going to need a common denominator. Not insurmountable, but inconvenient. Also, we're adding whole numbers with improper fractions, which means either we're going to need to rewrite our whole numbers as improper fractions, or more likely we'll want to write our improper fraction as a mixed number, so that we can work with mixed numbers here. All in all, this is working out to be terribly inconvenient. Maybe there's a better way. There's a better way. The better way is to rewrite all of our mixed numbers as improper fractions. And that will consistently be the method that we use for multiplying mixed numbers. This method exists, but it's just too inconvenient. We're going to do this the easy way. So, we had 2 1/4 times 8 2/3. 2 1/4, that's 2 whole things is 2 times 4/4, plus the 1/4 we had to begin with. That will be 9/4. 8 2/3, that's 8 times 3/3. 8 whole things is 8 times 3/3, plus the 2/3 we had to begin with. 8 times 3 is 24, so this is 26/3. 2 1/4 times 8 2/3, that's 9/4 times 26/3. So 9 times 26 over 4 times 3. And because I don't really want to multiply 9 times 26, I'm going to simplify this before I carry out any multiplication. I see these two have a common factor of 3. I see these two have a common factor of 2. And I see that that's it. So 3 times 13 over 2. Multiplying 3 times 13. 3 times 3 is 9. 3 times 1 is 3. So 39 halves. And since my problem was given in mixed numbers, I'm going to prefer to answer with a mixed number. So 39 halves. Let's see, 2 goes into 3 once. 2 goes into 19 9 times. 39 halves is 19 and a half. So I found that 2 1/4 times 8 2/3 is 19 and a half. And again, this is not the only conceivable method to multiply two mixed numbers, but it is by far the easiest. And so this is the way that we're going to consistently use. I'm going to give you one of these to try. Multiply 4 2/7 times 3 2/25. Pause the video and try this now. All right, so 4 2/7. That will be 4 whole things is 4 times 7 sevenths, plus the 2/7 I started with. 4 times 7 is 28. 4 2/7 is 30 sevenths. 3 2/25 is 3 times 25 plus 2 25ths. 3 whole things is 3 times 25 25ths. Maybe you know what 3 times 25 is off the top of your head. If not, 25 times 3. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. So 75 plus 2 25ths. 77 25ths. So our multiplication problem becomes 30/7 times 77 25ths. So we'll have multiplying numerators, 30 times 77, multiplying denominators, 7 times 25. Let's see. I immediately spot a common factor of 7 because 77 is 7 times 11, so I'm able to cancel a common 7. And I think I see a common 5 as well. 30 is 5 times 6. 25 is 5 times 5. So I cancel a common 5. I'm left with 6 times 11 fifths, or 66 fifths. Now, since my original problem was given in terms of mixed numbers, I think I'm in a situation where mixed numbers are convenient. I'll divide 5 into 66. 5 goes into 6 one time, with 1 left over. 5 goes into 16 3 times, with 1 left over. So if I have 66 fifths, that gives me 13 whole things and 1/5 left over. The answer to my multiplication problem, 4 2/7 times 3 2/25 is 13 1/5. Let's take a look at one more example where the simplification isn't quite as nice as we'd like. Let's suppose that we set out to multiply 4 5/9 times 26 2/3. Well, 4 5/9 is 4 whole things is 4 times 9 ninths, plus the 5/9 I already had. 4 times 9 is 36. 36 plus 5 is 41. 4 and 5/9 is 41/9. 26 and 2/3. Well, that's 26 times 3/3 plus the 2/3 I already had. 26 times 3 I'd like to write out. 26, 3 times. 3 times 6 is 18. 3 times 2 is 6, plus 1 is 7. So I had 78 plus 2/3 is 80/3. My multiplication problem then becomes 41/9 times 80/3. Multiplying the denominators, I get 27. Multiplying the numerators, well, I have 41 times 80, which I'd better write out. 41 times 80. I'm going to take advantage of this trailing 0. 8 times 1 is 8. 8 times 4 is 32. Add the 0 on the end. We have 3,280. And apparently no common factors. But we can still rewrite this as a mixed number by dividing 27 into 3,280. Fear not, right? 27 doesn't go into 3. It goes into 32 once. 1 times 27 is 27. We subtract. 5 remains. Bring down the 8. I think 27 goes into 58 twice. 27 times 2. 2 times 7 is 14. 2 times 2 is 4, plus 1 is 5. So, yes, indeed. 27 goes into 58 twice, with 4 left over. Bring down the 0. 27 goes into 40 once. Subtract. We get 13 left over. So 3,280 27ths is 121 and 13 27ths. And 13 27ths, it's easy to see. In fact, we cannot reduce. If we don't see how to simplify, we should convert to a mixed number, work with a smaller numerator. If we can simplify this fraction, we'll be able to simplify this one. If we can simplify this one, we would have been able to simplify this one. But rather than spending a lot of time messing around trying to find all the factors of 3,280, once we converted to a mixed number, it was clear that this fraction part is already in lowest terms, which means that this one was as well.